All right, in this video, we're going to just briefly spend a little bit more time with compound inequalities, and this is really just serving as a warm-up for additional practice today. So first, I thought we'd do one with a little bit of a story problem here, and I have used my adorably weird-looking dog as the model. I need to plan a diet for my dog, Missy. Missy consumes between 510 and 540 calories per day. If Missy eats 1.5 servings of dog food, how many treats can she have? And so, again, the question here is I want to give her the treats so that she stays within this range of calories and isn't below or isn't above. So, the way I'm going to approach this question is, maybe I'll do it different every time, but as I'm thinking about this, I'm going to write this statement. So, the calories that she consumes needs to be less than or equal to, I suppose. It doesn't say, it says between, so you could make an argument that it's probably not or equal to, but I think it seems appropriate. So we got to be less than 540, but we have to also make sure that we're above 510. And so this is the initial setup. And then let's figure out what we know about what she eats. So if she's going to eat 1.5 servings of dog food each day, then that is 1.5 times 320. So without doing the math yet, I'm just going to say that 320 times 1.5. So she's eating that no matter what. And then she's going to have some dog treats, maybe, unless this is too much calories already. So I don't know how many dog treats she's going to get, but if I give her one dog treat, it would be 15 calories. If it's two dog treats, then it's 2 times 15, 3 times 15. So what appears to be obvious to me is that I'm going to write a little plus to add the number of dog treats, calories from dog treats. But since I don't know how many dog treats, that's where the algebra comes in. So if it's 0 that we find out, then we're not adding any. If it's 20, then we've got 20. And so we now have this statement right here that we can solve. Now, I have by default, without mentioning it, turned this into an and question, because and is the only way we're going to be able to keep it within this range, right? If we're going to be greater than 510 and less than 540, or would not make sense in this case. It's looking for the overlap to get us between those two numbers. All right, so the first thing I should probably do is figure out what 320 times 1.5 is. So 320 times 1.5 is going to be 480. So this says 510 is less than or equal to 480 plus 15x is less than 540. And I'm well aware that we could probably just figure this out on our fingers and get the answer. But again, the point of learning algebra is so that we can solve more complicated problems. And so we're starting, showing you an example on what would be a fairly simple problem. So we still need to practice the right methods. All right, so the safe plan for solving this compound inequality, if you remember yesterday, was we're going to just rewrite it. So I'm going to write 480 plus 15x has to be greater than or equal to 510. So I wrote my variable statement first, right? And then greater than or equal, read from the variable, 510. Greater than or equal 510. And 480 plus 15x has to be less than or equal to 540. So it's a pretty small range here. All right, and now we're just going to solve it. So I need to get x by itself. And let's see, 510 minus 480 is going to be 30. So 15x is greater than or equal to 30 if I divide by 15. Then it looks like I have x is greater than or equal to 2. And subtract 480. And I get 15x is less than or equal to, let's see, that is 30 more than that one, so this would be 60. And let's divide by 15. and I get x is less than or equal to 4. So that means Missy can have between 2 and 4 treats per day to keep her within that calorie range. Again, a very simple example, but just as a quick example to show you how and where compound inequalities can come into play. All right, and then I want you to do just a couple of quick warm-ups, just exactly like we did yesterday. I would like you to solve each inequality, graph the solution, and then analyze what's on the graph to write the final solution. All right, so here we go. Part A, we're going to do just like we did the last one. I'm going to rewrite it. 2/5 x minus 8 is greater than or equal to -4, and 2/5 x minus 8 is less than 2. So I'm going to add 8 to both sides. 2/5 x is greater than or equal to 4. And now I'm going to multiply by the reciprocal to get rid of the 5/2. And I get x is greater than or equal to 20 over 2, which is 10. And I'm going to add 8 to both sides here. Going to multiply by the reciprocal. And I get x is less than, let's see, 50 divided by 2 is 25. All right, so before I put a box around this, I'm just going to make sure everything is good. And what I mean by that is I'm going to throw what I have on a graph and analyze it. Make sure the answer is what I think it is. All right, here's 0, here's 10, here's 25. I'm saying x has to be greater than or equal, so that way. And x has to be less than, not including, that way. And we're looking for the overlap because this is and so the overlap is going to happen right where we thought it would, in between 25 and 10. Okay? Please make sure you put the answers on the number line as we've been discussing. This is just scratch work up here. That's not your answer. All right, let's go ahead and give B a try. All right, this time I'm going to subtract 7 on both sides. And I get, and it's written backwards, which I'll just deal with for now. And I'm going to divide by -3, and the alarm bells are going off as I do this. I get x is, it swaps because of the divided by negative, and then that's 3. And then I'm just going to rewrite this because I don't like how this is written, and I'm just going to write it on the other side. X is less than 3, okay? So this is just me rewriting with the variable on the other side. X less than 3, x less than 3. Or I'm going to add 3 to both sides. Some of you get a little bit alarmed when this happens, but -3 plus 3 is 0, and 0 is a number. So we just continue on, and I'll just drop down here because now I know x has to be greater than 0. All right, let's take a look at what we got. 3 is over here. 0 is right here. Let's take a look. It says x has to be less than 3. So x has to be less than 3. Hey, that's interesting. And then x has to be greater than 0. The answer is not the overlapped area because we're looking for or. Or means if it shows up in either one of these statements, then it is a solution. So every blue point from here forever is an answer, and every red point from here is an answer. Yes, there's some overlap, but more importantly, all numbers are covered on this number line. So this whole number line consists of points that satisfy either of those statements. So the answer is all real numbers. Let's scroll down here and let's give these a try. Uh, can you come up with a compound inequality that has no solution? And the trick is here, I want a compound inequality. So that means using either and or, I don't care which. Can you do one that has no solution? Well, the answer is you cannot do it with an or, because as soon as you write any statement with or, the answers to those statements are some of the answers. So there's no way to have no solution using or. But and, we just have to write one that has no overlap. So I could say something like x has to be greater than 5 and x has to be less than 4, let's say. So then on a number line, we can see, here's 4, we'll call this 5, x is less than 4, and x is greater than 5, there would be no solution to that. I basically have already accidentally given away the answer to B. There is no way to write it with and, unless you're going to say something silly like x is greater than greater than negative infinity, and x is less than positive infinity, but that doesn't make a lot of sense. So the only way to do infinite solutions is when you do an or statement like we did on this example right here, and the two halves cover the entire number line. All right. Can you write one that has solutions greater than -2? Now, you could just write x is greater than -2. However, I want it as a compound inequality. So let's think about how we could do this. Here's -2. And let's say the answer is this. So what I could do is I could say, well, x has to be greater than -2. Or you could say x is greater than, let's say, 0. So then here's 0. X is greater than 0 would be all those points. But all those points are already covered by my first statement, so this statement becomes irrelevant. And the answer really is just x's are greater than -2. Okay. You could do that. You could do it with an and statement, I think. Let's give it a shot. If I said, here's -2, and I say x has to be greater than -2, and let's throw an and in here, and let's say and has to be, let's say x is greater than -5. Now with and, I'm looking for the overlap. So where's the overlap going to happen? Now I'm saying x has to be greater than -5, and x has to be greater than -2. So the overlap is happening at x is greater than -2. So once again, saying all of this together is irrelevant. I could have just said it easier as x is greater than -2. All right, that is not what we're going to be practicing today. That is just something I wanted to see if you could problem solve your way out of that. Today's assignment will just be practicing more of basically what we did up here in the second warm up, just getting a compound inequality and solving it and graphing it. All right, I hope this went okay. Make sure you ask questions in class if you need any help.